Hokie dokie. In this problem, they give us a function, so the regular original function f of x on the graph, and they give us the x values, the locations of the inflection points, as well as the mins and maxes. I might not have mentioned in a previous video that the definition of an inflection point is where the concavity changes. So, or from concave down to concave up. And so we saw that when we had the graph of f double prime, we just found inflection points at the x-intercepts. But when we're given the graph of f, you could really find them anywhere kind of in the space as long as they're essentially the change from either concave down to concave up or from concave up to concave down. And so they're telling us that the first inflection point is about here, 3.8, and the second one at 3.5. So when we put those dots on there for the inflection points, we can kind of see those separations in concave down, concave up, concave down, and so on. All right, so they're also giving us maxes and mins, so we can see those a little more clearly. 1.2 is that max, 6.3 is the location of the min, then 8.6 max, 9.6 min. You get the idea. So when we're answering this question, I usually recommend just looking at the statements and the graph. So like just referencing the graph to try to answer the statements. When it comes down to it, if something is like too close together, like how this is not very easy to see or distinguish, when you need to rely on these values up top, they can be helpful, but you can answer most of them, I think, without using them. So starting with option A, number 1, the graph is concave up from 3.8 to 7.5. 3.8 to 7.5, that's exactly where we talked about the inflection points. So in this case, the numbers do help, but really we could just visualize that it is concave up. It's opening up between those two x values. So that is a true statement. The graph is concave down from 7.5 to 9.2. So 7.5 to 9.2. Again, we can see that that is concave down. And then just another thing to confirm it could be looking at the numbers. So really, we don't need the numbers, but they kind of, reassure ourselves. So then number 3, they say the graph is concave up from 1.2 to 6.3. 1.2 to 6.3. Okay. Notice that these are the x values of the max and the min. Again, we could confirm that with this, but we can see it pretty clearly too just by looking at the graph from max to min. When we're at a max, the graph is concave down, right? And then if we go all the way to the min, the graph has at some point changed to concave up. So the generalization is, if they ever give you an interval from a max to a min or a min to a max, and they claim that it's the same concavity, concave up or concave down the entire time, it's not going to be right, because it must have changed concavity at some point in between. Namely, using our points at the top, 3.8 is the point of inflection, so that's where it changed concavity. So there's no way it could be concave up the entire interval from 1 to 6, right? So because of this being false, it makes the whole statement A false. All right, let's check out option B. They say concave down from 3.8 to 7.5. 3.8 to 7.5, we said that was concave up. So that is already false, making all of B already false. C, they say F is concave up, 3.8 to 7.5. We said that was true from option A. And then concave up 1.2 to 6.3. I believe that's the one we said was false in option A because it changes from concave down to concave up at some point. So that's wrong, which makes all of C false. And we move on to option D. Concave up, 3.8 to 7.5, that is true. Concave down, 7.5 to 9.2. We also said that was true from option A. Number 3, graph is not strictly concave up or down over 8.6 to 9.6. So 8.6 about right here to 9.6 about right here. We can see that that's pretty much a max to a min. And if we have a max to a min, we know that the concavity has changed some point in between those. And then if we want to confirm, we use our inflection points at the top. We say at 9.2, it has changed from one concavity to another. So that means it is not strictly concave up or down that entire time. So we break out the eraser to see that D is our answer. Let's go and do one more example as fast as we can. Starting with A. Concave up 49275. That is concave up. The graph is concave down 7.5 to 9.1. Again, pretty clearly concave down. Looks good. Number 3, not strictly concave up or down, 8.2 to 9.7. So 8.2 to 9.7 goes from max to min. And so when it goes from max to min, that is the case that it's not strictly concave up or down, because we know at a max it starts concave down, min it changes to concave up. So somewhere in the middle, namely looking at our inflection points at the top, 9.1, it has changed concavity. So this statement is true. And there's no need to check out the others. Hopefully the idea makes sense. If you have any questions though, please let me know. Hope this helps.